In this example, we have ourselves an angle theta, and we know that theta is going to reside in the first quadrant, and we also know that the sine of theta is 1/3. All right, and we're going to be looking for two values, so the tangent of 2 theta and the cosecant of 2 theta. If you'd like to go ahead and try these values first, go ahead and pause the video and do so, and then come on back and we'll work them together. All right, well the first thing we need to do, since we know the sine of theta is 1/3, let's go ahead and build a nice reference triangle. It'll be a right triangle, and we'll put our angle theta down here in this corner. And we know that the sine is 1/3, and sine is opposite over hypotenuse, so it will look just like this. And we can find this third side easily by doing our Pythagorean theorem. So 3 squared minus 1 squared. So 3 squared is 9, 1 squared is 1, 9 minus 1 is 8, and the square root of 8 will end up being 2 radical 2. Okie dokie. So here is my reference triangle. So let's go ahead now and look at the tangent of 2 theta. So tangent of 2 theta, and this is a double angle identity, and I have a nice one for tangent. It's going to be 2 over, and we're going to use cotangent of theta minus tangent of theta. And of course, tangent has a couple of different choices for the double angle identity, so I just chose this one. There are others as well. All right, so what do we need? Well, it's going to be 2 over, and we're going to subtract a couple of fractions. So cotangent. Well, cotangent is the reciprocal of tangent. Remember, tangent is opposite over adjacent, so that means cotangent will be adjacent over opposite. So it'll be 2 radical 2 will be my cotangent, minus tangent, which is 1 over 2 radical 2. And all that's in the denominator underneath a 2. Okie dokie. So let's go ahead and see how we can simplify this a bit. So 2 over, let's go ahead and get common denominators, and it looks like the common denominator is going to be 2 radical 2. So when I do that, I'm going to be multiplying this by 2 radical 2. And so 2 radical 2 times 2 radical 2 will be 8. So 8 minus 1 over that common denominator of 2 radical 2. Well, this numerator is really a 2 over 1. So this fraction here concerns itself with division, right? So we're going to be dividing by this fraction, but division is really multiplication by the reciprocal. And 8 minus 1 is 7. So wrapping this up, I'll have 2 times 2 radical 2, so 4 radical 2 over 7. And that will be my double angle then for tangent, as long as my initial angle theta has this sine value of 1/3. Okay, let's go ahead and do cosecant as well. So cosecant of 2 theta. And remember that cosecant really is a reciprocal function. It's the reciprocal of sine. So really we have 1 over sine of 2 theta. And sine has a really nice double angle identity. It's going to be 2 sine theta cosine theta. So once again, I'll have a fraction, 1 over, so 2 times. So let's go ahead and find the values for sine and cosine for our theta. So sine is opposite over hypotenuse, so 1/3. And cosine is going to be adjacent over hypotenuse, so 2 radical 2 over 3. And now we just need to simplify this. So 1 over. Okay, so 2 times 1 times 2 radical 2. So it looks like we'll have 4 radical 2 over, and 3 times 3 is 9. So this is 1 over this fraction, so we're already dealing with a reciprocal, so I'm just going to go ahead and take the reciprocal of this guy, 9 over 4 radical 2, and we can do a little cleanup by rationalizing this denominator. So really what I'm going to have here is 9 radical 2 over, well, 4 times 2 is 8. So what we saw here we had the sine of some angle theta that was in the first quadrant. We knew it was 1/3. So we built this nice right triangle based on the fact that the sine was 1/3. We found this other side. And after we did that, we were able to find these couple of values. And we did so by using the double angle identity for tangent and the double angle identity for sine, which then we took the reciprocal for the cosecant. So here are those two values respectively.